total change in y over the total change in x, right? That's average rate of change. So for instance, suppose you're, driving somewhere, right? For a trip, let's say, and you drive 300 miles and it takes you 5 hours to get there. Okay? What was your average speed? 60 miles an hour. That was your average speed. How did we find this? We took the total distance over the total time, right? So this is the total change in y over the total x. Now, as you are driving there, did your speedometer reach 60.0 every single minute of no, right? But this was the average. So that's the difference between average rate of change and instantaneous rate of change. If at a given moment you looked at your speedometer and it read, let's say 65, you're on the freeway, that would have been your instantaneous rate of change, but the average rate of change is this. Okay, so how do we find average rate of change? Well, it's this formula, f of b minus f of a over b minus a. So it's, what does that remind you of? Slope. That's exactly what it is. It's y2 minus y1 over x2 minus x1. So this is actually slope of the secant line. So if we go back here, right? Remember how we were doing this? If you take 2 points and if you find the slope of those, the line connecting those 2 points, that's the average rate of change, all right, of that function. Okay, so, like the most common examples for these are like velocity and position and so on and so forth. So average velocity, again, is the total change in distance divided by total time. Total change in distance in math and physics is also displacement, okay? What's the difference in displacement and change in position? Displacement tells you the direction that you've gone, basically. So if I start here, and if I take, 3 steps to, my right, I'm now 3 steps to the right of where I am, right? Because that has a direction, I'm 3 steps to the right, that's why it's displacement, all right? So displacement over time is this. So suppose you have a position. Position is usually given as S of t, okay, and it goes from T1 to T2, okay, that's the interval. Then, displacement is the position at T2 minus the position at T1, it has to be in that order, over T2 minus T1, okay, so how did you learn it when you were little? Or if you take physics now, final position minus initial position over the change in time, okay? All right, so take a look here. A water balloon is propelled straight up using a launcher. The height of the balloon in feet, the height of the balloon in feet, t seconds after it is launched, can be defined by this. So this is d of t, like distance, that's the height of the balloon. What was the balloon's average velocity between t1 and t2, t equals 1 and 2 seconds? So v average is the position, the final position, minus the initial position. By the way, yeah, put the phones like away. Just take them off of your desks, put them in your backpacks. D2 minus D1 over 2 minus 1. Okay, how do I get D of 2? You plug 2 into D, and it gives you 71 minus 54 all over 1. So V average will be 17 feet per second. Now, this is good enough, okay? Average velocity is 17 feet per second. Notice this is a positive value, okay? And that positive means it's going in the positive direction. Okay. Now, That's average velocity. Instantaneous velocity is exactly what you guys were doing for the homework for today. All right? So for that, you just have to use this formula here. Okay, and we just call that velocity, v of t. So it's the limit as h approaches 0, the position, s of t plus h minus s of t over h. Looks familiar, yeah? From yesterday. Okay. All right. Okay, this is like, yeah.
For this example, though, like, how did we get the 71 and 54?
How, you tell me. It's
like, what was the, you said the d value there?
d of 2, but you have a function given in their problem. Okay, so a window washer, this is like probably the saddest problem like that I solve in the year, because like the window washer drops his lunch off of the scaffold, right? It's probably not even like edible at some point. But afterwards, like, people pitch in and they buy him like a good lunch. So it's okay. It ends up being like positive. Okay. A window washer accidentally drops his lunch off of his scaffold 1,400 feet above the ground. The position of the lunch in relation to the ground is given as d, where time is in seconds and the position of the lunch is given in feet. Find the instantaneous velocity of the lunch, v of t, at 7 seconds. Okay, so v of t is going to be the limit as h approaches 0, d of t plus h minus d of t over h. Okay, so now I have a question for you guys. We have to find the instantaneous velocity at t equals 7. So how have you guys been doing it? Are you using method 1 or method 2 when I... 1? Okay. So let's do that one. So what's d of, let's do that work here, d of t plus h. So you're plugging in t later. Okay, so d of t plus h is going to be 1,400 minus 16 t plus h squared. So that's 1,400 minus 16t squared minus 32th minus 16h squared. Sorry, I did that quickly. I'm telling you, after a while, like I've now solved maybe like, I don't know, 500,000 of these problems. It really does. So when you square this, you get t squared plus 2th plus h squared, and then I distributed the 16 in one shot. So minus 16t squared. Okay? Yeah. Okay, so let's plug that in here. So this is going to be the limit as h approaches 0 of that minus d of t. So it's going to be minus 1,400 plus 16t squared all over h. Does that make sense? Okay, now let's cancel some stuff out. So minus 16t squared goes away. The 1,400 goes away. Again, do you see how the minus f of x or d of t cancels altogether? So now I have the limit as h approaches 0. Let's factor out an h. Negative 32t minus 16h over h. So v of t is the limit as h approaches 0, negative 32t minus 16h, which is how much? Negative 32t. So that's the velocity of the lunch at any given time, right? At t equals 1, the velocity is negative 32 times 1. At t equals 2, negative 32 times 2. Does it make sense that the velocity is increasing? Right? Yeah, because as it's falling, it gets faster, right? It's accelerating. So let's take a look at what's happening. This was the, so this is the situation, right? Like the lunch was here and it's now falling. Because it's falling in the negative direction, the velocities are all going to be negative values, right? Because it's going in the negative direction, okay? So v of 7 is going to be negative 32 times 7 which is negative 224 feet per second. Absolutely. Yep, okay. All right, so let's do this one. Similar. Yep.
The very final answer, do we have to write T of 7 or can we just write negative 220?
Okay, so if you don't write V of 7, it will not be wrong. However, I really would like for you to get in the habit of writing V of 7, especially if you would like to take calculus, or especially if you want to take AP calculus, because these things make a difference. In calculus, you have to label things the right way, because otherwise, like, things get all sorts of messy. Okay, let's take a look at this next one. Okay, the distance in feet, this should say in feet, of a water rocket from the ground after t seconds is given by S of t. Okay, so find the instantaneous velocity. All right, so, okay, so this is going to be S of t plus h minus S of t all over h as the limit as h approaches 0. Okay, I'm going to give you 90 seconds to do this. Okay, on your mark, get set, go. Awesome. So this is at any time t, and then if you wanted to find it at a specific time, you would plug it in. Oh, that was the timer I had set for you guys. Okay. So given the position function here, now it's in x of t, where the position expressed in units of meters, find the average velocity. You okay? Yeah. Okay, average velocity, what are we going to do? Right. Old-fashioned slope, right? So x of 5 minus x of 1 over 5 minus 1. It's important to show this step. Remember, it's not about the final answer. It's about the process. Once you do this, right, x of 5 is what? 75? Yeah, minus 3 over 4. It's funny how, like, I can do the complicated stuff, but when it comes to, like, 3 times 25, I'm like, I need my calculator. So how much is that? 11. All right, I'm going to take your, is it? No. 18. Okay.
I added a 1 to the 3. I got a 31.
18. That's why I solve them all out before I come here, because I also don't want, yep. Okay. Huh? No, I just, we need to be on top of things. We can't, right. Okay. So, units. What units then?
Meters per second.
Meters per second. Fabulous. And then the instantaneous velocity is, okay, so V of 4. Let's do method 2 on this one, just because. So here's how you do this. V of 4, so we're going to do x of 4 plus h minus x of 4, huh? Oh my God, I'm losing minus 1s. I'm losing 1 point everywhere. V of 4, okay, over h, right? So this is the limit as h approaches 0. X of 4 plus h.
Don't you have to plug it into the 3t squared?
Yeah, I'm going to do it right now.
Okay.
So it's going to be 3 times 4 plus h squared minus 3 times 4 squared all over h. So how much is this? Here, this is 3 times 16 plus 8h plus h squared. So what's 3 times 16, Zeev? Come on, you're going to redeem yourself. There you go. 48 plus 24h plus 3h squared minus, how much is that? I bet it's 48 because it's got to cancel with that one, right? You got to have faith in the math over h. So the 48s do indeed go away. Factor out of h, 24 plus 3h over h. Whew. And finally, 24 meters per second. Fabulous. Yep.
If we don't want to use that method, do we have to know it? Or?
Nope. But I do want to, I want to give it some time because, it's good to know both. Right? It's good to have a plan B. Yes.
So how do we know it's like with the? I'm just confused like with the units. How we know it's like meters per second?
Because it tells you that position is expressed in meters, and it doesn't tell you what's. We just assumed seconds. Oh, does it? Oh yeah, and these are seconds.
But how do we know like which one goes on top?
Oh, that's a good question. Well, first it's velocity. Okay. So you know that velocity is meters per second. But also, look at the numerator here. The numerator, what is this? This is position, right? Position, this is all like 75 meters minus 3 meters over 5 minus 1, 4 seconds. So it's got to be meters per second. All right? And it's the same thing here. H is on the x-axis, which is time. And then this is the function, so it's in meters. Okay? Okay. Okay. I meant to fix this problem, but it looks like I still neglected to. An object is thrown straight down. The total distance y the object falls can be modeled by this function. So here's what we're going to do. This is from the book, and the book doesn't have a negative in front of it either, but it's got to have a negative. So let's put a negative because, by the way, do you guys know what that negative 16 is for? It's everywhere. It's in, if you look at the problems that we've done, they all have that negative 16t squared. Why is that? It's the acceleration due to gravity. So in meters per second, acceleration due to gravity is 9.8 meters per second squared. But in feet, it's 16. And because it's going down, it's got to have negative 9.8, t squared. If you do it in meters, negative 16 t squared if you do it in feet per second. So all of the problems that are in free fall, if it's in feet, it's got to have the negative 16 t squared in the equation. Okay? I know, I always prefer meters over seconds, but the books, I don't know. I mean, don't even. Yeah. Okay, so if an object is thrown straight down from a height of 816 feet, and it takes 6 seconds to hit the ground, what was the initial velocity of the object? Huh? It's just algebra. That's all it is. So take a look at this one. Y equals negative 16t squared plus v naught t. That v naught is the initial velocity, right? So we're going to have here 816 is equal to negative 16, 6 squared, because it takes 6 seconds, plus v naught times 6. So, yep. Okay, so how much is that? I think you have to divide by 6. Right? Divide. And then did you do v naught times 6, that part?
Yeah.
Was it
You're
232?
adding negative 16 times 6 squared instead of subtracting it.
It'd still be a positive number.
No, isn't it just 4? That's what you get if you subtract.
Yeah, if you subtract.
No,
And then if you
divide by 6.
add. Yep, 232. You're right. Sorry. I was looking somewhere. So it's.
The minus sign in front of the 16, right?
Yeah. Okay. What is the average velocity of the object? How are we going to find the average velocity?
Oh, this is slow.
This is the slope. Exactly. Huh? So the average velocity, yeah, so you have to do, What is the initial height?
800.
816. What is the final height? 0 over 6. Yes. Oh, sorry. Oh my gosh. Oh my God. I must be getting hungry. This is why, by the way, this is going until 11:30 because I know by 12, like, I just get hungry and, like, I can't do any more math. So this is why I'm stopping that at 11:30. So how much is that going to be?
Whatever, negative 800.
Right. What is that? We're going to take the pressure off of Z of somebody else, huh? Negative 136 feet per second. Okay? Oh, and it looks like that's where we're ending. Okay? All right. So that's where we're going to stop today.